Hello friends, in this video we will learn how to program the internal EEPROM of the Arduino. Here we will be concentrating only on the internal EEPROM and we will not deal with interfacing with an external EEPROM chip, for example 24C02 or 24C04. This video is purely for the internal EEPROM. All the code will be written in Arduino C using the Arduino IDE. Here we will be using the EEPROM.h library. The first thing we are going to do is to read and write a byte into the internal EEPROM. This is the easiest one to do, so we'll start with that one. After that, we will write a float or a double data type into the EEPROM. So you can store numbers with the decimal points inside the EEPROM. Then we will also store a string of variable length in the EEPROM. Then finally, we will use a struct data type to store a structure with different types of data type. For example, a structure containing name, age, temperature, all having different data types will be stored in the EEPROM. You can download the code from our GitHub. The link to the GitHub is in the description. So do check it out. Now these are the supported boards. Here we have the usual Arduino Uno, which contains the Atmega 328 microcontroller. We will be using this particular one because it is the commonly available one. And it has around 124 bytes or 1 kilobytes of EEPROM. If you want something with more EEPROM size, you can go for the Arduino Mega, which has the Atmega 2560 microcontroller. And it has 4 kilobytes or 4096 bytes of EEPROM. This tutorial will also work with other boards like Arduino Nano, Arduino Micro, and Arduino Leonardo. They have different types of microcontrollers and varying EEPROM sizes. For example, all the other one, Nano, Micro, and Leonardo has 1024 bytes and Mega has 4K. Now this is the internal diagram of the Atmega 328P. You can see the EEPROM here and it is having the size of 1024. So we'll be using Arduino C, so we don't have to deal with the registers and other stuff that are normally required in embedded C programming. So we'll be going for the programming. This is the logical structure of the EEPROM. We have an address and we have a place to store the data. This is the memory cell and its size is around 8-bit or 1 byte. So you can store a 1 byte data here. And you will have to provide the address. For example, you have to provide the address 0 to store a byte or address 1 to store another byte. So some of the data type may occupy multiple cells. So that requires a different function. So I'll teach you that in the later sections. So the addresses of the EEPROM ranges from 0 to 1023 for the Atmega 328. If you are using the Atmega 2560, it may start from 0 to 4095. The size remains the same for each individual cells, all are 1 byte. Now these are the EEPROM functions we will be dealing with. The first one is called as the EEPROM.length, which is used to determine the size of the EEPROM of the particular microcontroller. If you run this particular function, it will return the size of the EEPROM. For example, in the case of Arduino Uno, it will be 1024. In the case of Arduino Mega, it will be 4096. Now the write and read are functions that are used to send a byte, read or write a byte into the EEPROM. Now let's say you want to store something that is bigger than a byte, like a float or a character string. You can use put and get methods. So I'll explain that in the later sections. So if you like this, do like and subscribe. For my tutorial, I'll be using an Arduino Uno development board. Now Arduino Uno has an Atmega 328P microcontroller, which is a 28-pin microcontroller made from microchip. The microcontroller, that is the Atmega 328P, has an internal EEPROM capacity of around 1 kilobyte or 1024 bytes, this one. Now we will read and write to this particular EEPROM using the Arduino IDE. So here I am using the Arduino IDE and I have selected the board as Arduino Uno, which is connected to COM3 of my serial port. Now, to access the EEPROM capabilities of the Arduino, you have to include the header file EEPROM.h, this one. After that, this is the normal setup. We have a void setup here and a void loop. Now we won't be using anything inside the loop here. We'll be sticking mainly to the setup part. So we will be sending all the information to the PC through the serial monitor. You can access the serial monitor from here. So we'll be using serial interface to send the data from the Arduino Uno to the PC so we can view the information. Now here we will learn how to check the size of the EEPROM for a particular Arduino board. You can use this code for both Arduino Uno and Arduino Mega. The difference is that Arduino Uno has a 1 kilobyte EEPROM, while the Arduino Mega is having a 4 kilobyte EEPROM capability. So you can store more data on the Mega one. Here I'll be using the Uno one. That means that I will be limited to 1024 bytes of EEPROM. To measure the EEPROM length, we have a function called as EEPROM.length. This is provided by the EEPROM.h header file. So if you run this program, if you run this function, it will return the size of the EEPROM in the form of an unsigned int or just a normal int. So that data will come here and we can use it to send that information back to our PC like this one. So I'm going to run this program. From here you can upload it. So I will open the serial monitor now. And from here you can see that the EEPROM size is equal to 1024 8-bit locations or 1024 1-byte locations. Now if you're running this on an Arduino Mega, it will come as 4096. In this program, we will learn how to read and write to the internal EEPROM of an Arduino Uno board. So here we will be using the EEPROM.h library for calling the functions. Now we will use two major functions. One is known as the EEPROM.write, this one, and the other one is called as the EEPROM.read, this one. Now both of these things are used to read and write to the EEPROM library. Now one thing you have to remember is that EEPROM has a limited lifespan. So if you continuously read and write to the EEPROM, the cell may get corrupted. So you can the lifespan is around 100,000 life cycles. So if you continuously read and write, you can destroy the memory cell at that particular junction. The other thing you have to consider is that the write operation takes some time, around 3.8 milliseconds. So we should factor in that into our program whenever we are doing continuous read or writes. So we'll go back into the program. So here we'll be writing a value 25 to the EEPROM location 0. This one. This is the address of the location. So it is the first location we'll be writing to it. So the value we are going to write is 25. So we will be using this EEPROM.write function, and we will first give the address. So that will be 0 here. This one will be 0, and the value to write, that will be 25. So when executing this particular function, the code will write the value 25 into the EEPROM cell whose address is 0. That means the first one. Now we will read it back using the EEPROM.read. For that we have to give only the address. So here we will be giving the EEPROM location address. So that is 0 here. So the function will read the data and will send the data to store the data in this particular variable, which is value. Now we will send the data back to the PC. For that we will be using a serial.print, where first we will send the EEPROM location and then the data, that is the letter 25 here. So I'll run this code. You have to open the serial monitor. And we are uploading the code right now. Now you can see that the EEPROM location is equal to 0, which is the first address, and data is equal to 25. If you want, we can change that. I can give a different location here. For example, let's say it's 22 and the value is 250. So this is the new location. EEPROM location is equal to 2, or the address is equal to 2, and data is equal to 250. For the Atmega 328P, that is the Arduino Uno, there are 1024 bytes. So the addresses range from 0 to 1024. So you can use addresses from 0 to 1023. That is 1024 locations. And each of these locations can store a single byte. So we have to be careful that when we are using this particular function, you can only give a maximum value of 255, because then it will be bigger than 1 byte and the value will not be stored properly. For example, I will show you. If I increase that value, I'll be writing to the same address. As you can see that from here, we are storing the value 258, which is more than the 8-bit size that is available to us. So the data is not properly stored, and only thing you can see is 2. So only the lower address bits are, the lower data bits are stored. So I'm using the programmer calculator from the Microsoft Windows, and I have entered the decimal value 258 that we were trying to store in the 8-bit location. As you can see that the value is more than 8-bit, the 1 is here, and only the lower part of the 8-bit is stored here. So that is 0010. That is binary equivalent for 2. That is the data we are getting here. So if you want to store more than 255, we have to use a different method. I'll tell you later that. Now, if you have any doubts regarding this one, do put it in the comment section. I will try to address that also. All the codes that I have explained in the tutorial is available on our GitHub repo. You can download it by going to this particular link. And I have put the link in the description. So you can click it from there. And if you want, you can download it directly from here. Download as zip. So these are Arduino files. You can open it directly with the Arduino IDE. We also have a website. So you can, there is a textual description of this tutorial also there. You can check it from there. Now this particular program is similar to the previous one that I have shown to you. Now here we'll be using both read and write, EEPROM.read write and EEPROM.read for storing some data. Here I want to show you that you can also store ASCII text like character A, character T, like that to this particular EEPROM. For that you have to use the same EEPROM.write. You have to give the address, that is 0 here, and you have to give the character, that is A. You have to use single quote A here, so that the data is formatted as an 8-bit ASCII. So this will store the letter A, capital letter A, at the location 0. Then it will store the letter T, this one, at EEPROM location 1. We'll also store 1 and 6, which are numbers, at location 2 and 3, like this. So this will show something like 8016. So when we are reading this data, the data that is you're reading from the first location, that is the character, we have to convert it back to character. That is what we are doing here. We are using the EEPROM.read to read the location 0, that is this one, which contain the binary representation of ASCII A. Now we will give the character, and which will convert the binary to the character representation, and that data is sent to the serial.print. Then you can see that in the serial monitor. Same here also. This is only required for displaying the characters like A and T. Here I will be showing the same thing, like what happens when you try to store a value that has more than 8 bits. So you can run this program and it will show you how the data is stored. So I'll run this code once more. As you can see, the text 8016 is there, and then 255, that will be this one. Then we are storing 256, which is more than 8-bit, so it's not here. It's stored incorrectly as 0. And then we will try to store 341, which is also more than 8 bits. So only the lower part, so it will show only 85. So this one. In the previous example, we learned how to read and write a byte value to the EEPROM memory of the Arduino. Now let's say we have to write a value that is bigger than 1 byte. For example, floats or double values are bigger than single. So we have to have a convenient way to write these type of values. So in this example, I will show you how to write a float into the EEPROM memory of the Arduino. So we'll use the same function the same library, EEPROM.h. And here we will be using two functions which are known as EEPROM.get and EEPROM.put. Both are used for reading and writing into the EEPROM memory for values that are bigger than 1 byte. So I will be storing some float value here. We have a float value here, which is named as float value underscore 1, and it has a float value of 111.11. Now we have an EEPROM address, also the starting EEPROM address. Now I will explain the EEPROM.put function, which will write this data into the EEPROM. So for this function to work, we require two things. First one is known as the EEPROM start address, and the other one is the name of the variable which we want to write. So that will be this one, name of the variable, and this is the start address. So we'll be storing our value in the first section. So the start address here is 0. Then we will give the value, that is this one, float value. So when this function runs, the EEPROM.put function will put the data into the EEPROM, and it will occupy the bits, the addresses 0 and 1. So 2 bytes for storing the float value. Now to read that value back, we have to use something called as an EEPROM.get function. This is the function. So EEPROM.get function returns the float value. So we need to put a float value here to receive that one. For example, we have to create a new float value, let's say. So this function EEPROM.get will return this particular value. So when you run this program, the EEPROM.get will get that data and save it into the val variable. This val variable, you can send it to the serial port and it will be displayed on the terminal. Earlier I have just put the function inline with the serial.println. We will run this code and you can see the value right here. In this program we have multiple float values which are named as float value underscore 1, which will be 111, and float value underscore 2, which will be starting with 2, and float value underscore 3, which is 33.333. So we will store all these three values inside the EEPROM. Now these are the name of the variables. Now we have to calculate the EEPROM address. The first EEPROM, the first data, that is the float underscore value underscore 1, this particular one will be stored at this particular address. That is, the starting address will be 0. So now we know that the float is 4 bytes. So it will occupy 4 bytes. So here we are setting the second address, this one, after 4. So we are using the size of operator to get the size of float. So this will be 4, and the second EEPROM address will start from 4. Now the other one will take another 4 bytes. So it will be starting at 8. So by this method, we will be giving the program the starting address of all three values, which will be stored sequentially on the EEPROM. So we are doing this one here. We are writing the data. This is the EEPROM address 1, that will be 0. Then on that location, we'll be writing this particular value that will come right here. And then we'll be writing the second value, that will be this one, using this particular line, and the address will start from 4 because the previous one it took the first 4 bytes. Okay, like that. Second one, third one also is written, and then we will use the EEPROM.get function to get the data from all these memory locations. Here it will try to read from the memory location 0 and then the next 4 bytes. So we'll get the value of this particular one, 111. Then in the second one, it will start after 4 bytes and start reading. So in this way, all three values can be read sequentially. So I'm going to run this thing and we can find all these three values here. So this is how you can store multiple float or double values or integers in the EEPROM. The important thing is to calculate the size of each data type. So if it is an int, we have to calculate the size of int. And if it is a double, which is same as float actually, so we can use that particular value here. Now we are going to store a string of text, this one, hello from Arduino, into the EEPROM. For that, we will be using the put function and the get function. So first we create a character array text into which we will be storing this data, that is hello from Arduino. And then we will write that information into the EEPROM, starting from the EEPROM address 0. So we will give the EEPROM.put for writing the data, and we will give the address here, and then the name of the array, that is text here. Then the data is written into the EEPROM, and then you can get that data by using the EEPROM.get. And for that we have to give the address, starting address, and the name of the array. So this is written in line right now. So whatever data is coming from here is directly sent into the serial.println. So it will be displayed in the serial monitor. So if I run this, we can see the data hello from Arduino. Here we will learn how to store a structured data type into the EEPROM of an Arduino. Now I have declared a structure which is called a struct, my struct. Now structure is a data type that can contain different types of other data type. For example, I have declared a structure called my struct, which contains a float variable, a byte variable, and a character array. Now this can be used to define other variables of this particular type. So structure can be used to group dissimilar items as a single data type. Now we are going to store this particular structure inside the EEPROM. Now we have declared it here. Now inside the setup, we will declare a structure variable of type myStruct. That means this mySt will have the same structure as this one. And we will then store some values. So the first one is float. So we will send the data 12.56. The other one is byte, this one. So we'll put only 8. And we'll also give a character. So I'm going to put hello. So this all data will be stored inside the structure mySt. And we will store the mySt structure in the address 0. That is, the starting address will be 0. And the rest of the items will be stored sequentially after that. So for that purpose, we will be using the EEPROM.put function, and we will use the same method as we have used earlier. We have to give the starting address, this one, that will be 0, and then the name of the structure variable mySt. So this will store the structure into the memory. Then we can get that data by using this particular EEPROM.get. So when you call EEPROM.get, the function will read mySt and the data will be transferred. So you can access the data by calling the individual elements. So we will call the first one, the float variable, this one, which we have declared earlier as f. So if you call this one, it will show 12.56, and next one is the byte, which we have called as b. So this one, then it will give the value 8. Then we have to give we have to call the text one, which will display the data hello. So this is how we will display the structure variables. So if I run this thing, I will run it now. So in the serial monitor, you can see that the first one, myst.f, that is 12.56, and 8, that will be this one, byte, and hello. Now I have changed the declaration of my array. I have removed all the values. A few seconds before, we have written these particular values to the EEPROM. So when we are using the EEPROM.get, all that data is actually stored into this particular variable. So I will show you. It will be reading the data from the EEPROM. So this will have no effect. I will just, so you can see there is no change, even though we have changed here. So whenever this is the reading, all that particular data is sent to this particular variable. And from there, we are individually displaying this particular data. We can also store multiple structs inside the EEPROM array. So I will show that next. Now in the second program, we will store two structs inside the EEPROM. Now we'll be using the same structure, this one, but we'll be creating two different structure variables. So it is similar to this one. We'll be storing the first struct, myst, at EEPROM address equal to 0. Second structure, that is this one, myst2, will be stored at a different address, but we will change that later. So here it will be 0, but it's not 0. We will change it later. So the mystruct, first one, will contain these particular values. It has 12.56 float, 8 as byte, and a hello for text string. The second one will have 34.56, 6, and volt. Now we have two structs, and we will store the first struct here, and we'll be storing the data with the static address 0, this one. And then we will give the name of the structure that will be stored here. Now we have to calculate the second address. So for that, we will be using this one, EEPROM address 2, and we will use the size of operator to get the size of the first structure, this one. Then that will be given to this address. So if it is a 4, the address will start at 4. Now we will use that data to store the second structure. Now we are using the same thing, get function, to get both of these things. Then we are displaying it here. So if I run this one here, this is the parameters from the first structure, and this is from the second one. This is how we store two different structures in the EEPROM. Now, if you have any issues with this, do put it in the comment box. I will try to explain. And if you like our video, do like and subscribe.